Hello, welcome to 2-7, Day 1, Parent Functions and Transformations. So this is going to be into a two-part lesson. The first one, we're going to cover just the first 3 pages, so we're not going to cover all of 2-7 all in one video. So let's get started. We're going to first just talk about the different types of graphs. So family of graphs, a group of graphs that display one or more similar characteristics. A parent graph is the graph of the parent function, which is pretty much just the simplest graph that is kind of the original before we've transformed it or done anything to it. So let's take a look at these different types here. We have a constant, which is just that horizontal line. We have a linear or identity function. We have absolute value, kind of a V shape, and then we have quadratic, and then we'll talk about a few more. So let's just first identify these types. So this first one is absolute value. So just kind of getting you to recognize the different shapes. The next one is quadratic, kind of a U shape. And then the last one there would be linear or identity. All right, so what transformations are transforming in a word that actually describes what it means in math, right? So like Transformers movie, where that car transforms into the robot. This isn't as cool as that, but still pretty cool. So transforming, we have different types. We have ones that move a figure up. We have ones that move the figure down. We have ones that move the figure left or right. Reflections, we've definitely already seen that before, but that flips a figure over a line called the line of reflection. So it just flips it over that line of reflection. A dilation is what we're going to get into on our next video, and that's shrinking or enlarging a figure proportionally. So these first few are pretty easy since we're just moving it up, down, left, right, and reflecting. So this looks kind of crazy, I know, but bear with me. So this right here is the original parent function, no translation. It's starting at 0, 0, and it's just that basic x squared parent function. So notice that our equation here, if we have a plus or a minus behind our parent function, that's going to move it up or down. So anything that's outside of our original parent function is vertical movement. Okay, anything on the inside, see how we have parentheses here? Think horizontal, or our H, and think hug the inside, like you're bringing someone in to hug you tight in the inside. So horizontal is inside, and that moves us left or right. So outside is up or down, inside is left or right. So it's based on kind of where that positioning is. And what I'm going to do for our examples is if they were squared or cubed, I'm going to change them all to absolute value because it's a lot easier to graph that V shape. So just bear with me as I make a couple of changes every now and then to what we're doing. So here's the general form. It looks kind of crazy looking, but we might have something out front. That's going to be the next day. Our stuff that's inside that H was our horizontal movement. And then out back there, our K is our up and down movement. So what we're going to do is identify kind of where we're starting, and then we can go ahead and graph that. So let's start with first just describing, and I'm going to change this. So here's our first change. Change this to absolute value and just get rid of that little square there. So ignore that. Okay, so we just have the absolute value of x plus 1. So our original absolute value, if you remember from the beginning, was just a V shape and starting at 0, 0, and just kind of going out from there with a slope of 1. So there's our original parent function. Now we're going to go ahead and graph this transformation. So remember, when something's on the inside, that's horizontal. That's H. The other thing we need to remember is that since there's a subtraction, it's always in that form with a minus sign, we want to think opposite. Opposite thinking when it's on the inside. So if it's a +1 and we're moving horizontally, I want you to think the opposite of a +1, because really it's a double negative. We have that subtraction that's a part of the form, as you can see here. So really this is a -1. So that means we're going to move horizontally and we're going to move left 1. So that's why that +1 gets a little bit confusing, since the fact that we're moving left and not right. It's opposite thinking. So we move left 1, and now we can draw our new absolute value function where we have a slope of 1. That's why I'm kind of keeping it absolute value. It's easier to graph. And there it is. It just moved left 1. So that's what I'm going to write down below here as our transformation. And our new vertex point, as you can see right here, is at -1, 0. All right, so let's take a look at the next one. So I'm just going to first draw our original parent function. Okay. And we are going to look and see what's happening here. So nothing's on the inside. We have something out back here. So that means that we're moving vertical. Anything on the outside's vertical movement. And that's just going to take some... Oh, sorry for the announcement. We are going to take anything on the outside, and that is going to be moving it vertically. So if it's a +2, it is normal thinking of, okay, we're going vertically up 2. So 1, 2, and we're going to our vertex point moving up 2, along with every other point. So from that, slope of 1, slope of 1. Another way that we can do that will kind of help us is we can see our vertex point of where we're going to start from our graph without even knowing where we're moving. So this H is always going to be your coordinate or your X coordinate there where you're going to start, and the K is always going to be your Y coordinate. And remember, it's going to be opposite thinking though for that H. So notice that we had nothing in here. That's a 0. And we have a 2 out back, so that's our 2. And is our vertex at 0, 2? Yep, 0, 2. There's our vertex point. So you can tell whatever's on the inside is going to be your X coordinate with opposite thinking. And then whatever's on the outside is your Y coordinate out back there. And you can know where to start without even knowing kind of what to do. So let's go ahead and describe the transformation that's taking place on 3, 4, 5, and 6. And I know they're not all absolute value, but that's okay. We can still describe that transformation. So think horizontal, hug the inside. So inside stuff is horizontal movement. Anything on the outside is going to be vertical movement. So for number 3, we have inside, so that's horizontal, and we have to think opposite. So instead of that plus being a +3, it's really a -3. And -3, if we're moving horizontally, like the horizon, is going to be left 3. So that's going to move this graph, or this absolute value function, left 3. All right, the next one, we have outside. So that's vertical movement, and it's -4 or down 4. So vertical, remembers up and down. So if it's a negative, that's down. The only one that's that opposite thinking is when it's on the inside, which here this next example is. So inside, think opposite. So we're thinking a +3 horizontally would move us right 3. Try that last one on your own. There's actually two that are taking place. So remember, anything inside here is horizontal. Anything outside here is vertical. And tell me how it's moving. Don't forget opposite thinking. So pause the video and I really want you to try that one on your own and then press play to check. All right, hopefully you have moved left 2 because it's opposite thinking and horizontal movement, and then here is vertical thinking, so it would be down 1. All right, let's move on to a couple more examples of, this time, reflections. So we have our original, we have it reflected over the x-axis when it's on the outside, which is the same thing as vertical movement, right? So we're kind of moving or flipping it vertically, and see how it's outside. And we remember from our last page that outside is vertical movement. So think vertically flipping it over that x-axis. And this one again is just another one that we're going to have to kind of memorize, and we will see this in all the chapters too, and you will become very good at it. So make sure that you're practicing now. That will make the next chapters a lot easier. Anything on the inside's horizontal movement, and we're kind of moving horizontally here of reflecting it over the y-axis. So inside, remember, is horizontal. So wherever that negative is going to tell you what axis you're moving over. So let's take a look at these examples here. And we're going to take a look at our first one, number 1, and we are going to first just graph the original parent function. All right, so since our negative is out front, that's vertical movement, so we're going to be reflecting it over this x-axis and flipping it vertically down. So there's our new one, and if we go ahead and change, whoops, not that. There we are. I'm going to change our colors here so you can see it a little better. There we go. So our original is the black V, and our new, that's been reflected, would be our red. Let's go ahead and do this next one, although I am going to change it into absolute value and put it on the inside. So if we are going to take and have our parent function, graph that original parent function starting at 0, 0. All right, and we're going to reflect it this time, and since it's on the inside, horizontally. So if we were to go ahead and do that, let me go ahead and group this. So let's go ahead and do it this way. We're going to flip it left to right. And notice that it's not really changing. It's going to still, since it's going this direction, kind of mirror itself. And it looks like it really hasn't changed at all, but it has been reflected. It's just been reflected over the y-axis. So let's go ahead and answer these last 4 questions of how it's being reflected. So remember, inside is horizontal, and horizontal goes this way, which means it's going to go over the y-axis. So it's reflected over the y-axis. This one's on the outside, that's vertical movement, which means it's going to go up and down, flipping it over the x-axis. So try those last 2 on your own, and then you can check. And since this one is on the inside, it should be over the y-axis that's being reflected. And this one actually has both, so inside and out, so over x and y axis. All right, so that's the end of that first lesson. Just remember that you can find your beginning vertex point, opposite thinking what's on the inside, and then on the outside is your y value.